Hi, welcome to lesson 17, basic solutions in canonical form. I want to note that this is really combining two of the big definitions that we've gone over. And what I'd like you to do is to go back and really review both of these from the previous lessons. Okay, in particular, review basic solutions, as this really contains the idea of defining a unique point from our constraints. And that relies on a few different definitions, in particular active constraints, linearly independent constraints. And note this other condition that it satisfies all equality constraints, something that we perhaps haven't really discussed as much. We've been really focused on this one. And then also look back to the previous lesson where we talk about this special canonical form. The idea that we're going to really look at today is how this definition of basic solution works in the canonical form. And what we're going to see is that it actually simplifies our lives somewhat. So before we start, this video is going to end in just a second. What I'd like you to do is go back, do exercise 7.2. You're going to need it for the assessment anyway, so it's going to help you for that. And really pay attention to how verifying a solution or verifying a set of constraints corresponds to a basic solution, or finding all the basic solutions for a polyhedron. These are all related ideas. And really, you exercise the latter one for exercise 7.2 really relies on you doing a fair number of calculations. And what we're going to see today is that those calculations get simpler when we have canonical form. They are the same calculations, of course, but because of the specific kind of form, all equality constraints for the complicated constraints, and then the inequalities are all simple variable bounds. This makes our lives easier. The reason why is because we have a lot of linear algebraic techniques for equality constraints, and we don't for inequalities as much. And that's what we lean into. Anyway, go ahead, do exercise 7.2 before you view